Intersecting chords. We'll study this diagram in front of us about these two chords that are intersecting. The intersecting chords we're talking about here in this case are chord AB and CD. These are two chords that are intersecting. Now when these two chords intersect, of course, now some of the properties that you should be aware of is, by common sense, you will know that this AD is a chord on its own. AD is subtending this kind of angle to the circumference. Then you're also having the same chord AD subtending an angle to that other circumference. So it means this angle and that angle is the same. So it means angle ACD is the same as angle ABC. Likewise, this chord CB, it is subtending an angle to the circumference, and this is also subtending an angle to the circumference, the same chord. So it means this angle here is the same as that angle here. It's the same when you look at it from this way. When this is also a chord. Remember, a chord is just a line that connects any two parts of the circumference. So when you look at this chord, it is subtending an angle to that point, and also this same chord subtending an angle to that point. So you find that this and that are the same. It is the same with this chord. It is subtending an angle there. It is subtending an angle there. So it means that this angle and that angle are the same as well. So this seeks to explain that BCD, which we've just talked about, BCD is equal to BAD, is equal to BAD. These two are the same. Also ABC, which is ABC, this one is the same as that one, ADC. Same stuff. Then we have CPB, which is CPB is equal to APD. These two angles are also the same because they are vertically opposite angles. It's the same with these. This angle is also the same as that angle because this and that they are also vertically opposite angles. That is from our angle properties. Then since we've realized that this triangle is similar to that triangle, then it means that PC over PA is equal to PB over PD. Because this triangle is similar to that triangle. It's the same with this one. This triangle also is equivalent to these triangles are similar. So that's how we interpret when the chords are intersecting in that kind of way. Looking at the next category of intersecting chords, we are having these chords running, but they are going out and they are meeting outside at X. These chords are meeting externally. And if you look at this diagram, we are having a line here. This line is parallel to that line. When this line is parallel to that line, it makes this triangle, which we are calling AXC, this triangle is similar to that triangle. Now, when this triangle is similar to that triangle, it means that XA over XB is equal to XC over XD. We deal with them like they would deal when we're dealing with figures that are similar. Now, please take note that these are only similar, only if these two lines are parallel. We have another case whereby we are having a chord intersecting with a tangent. Now, this tangent, if you take a closer look, you will notice that it is having point A and B. Points A and B are still parts of the tangent. They are parts of the tangent, but they are very close. Part A and part B are too close to the tangent as it is passing by. And of course, here the R write-up says that if M is the midpoint of intersection of this AB, which is this line, and CD, which is that line, we are having chord AB, which is too small, and CD. When these lines AB and CD prolong and they meet at point M, when they meet at that point, and the thing is that A and B are so close, so much that they meet at T, then it means that ABM becomes Tm. It means that this value of T is more of a representative point to represent A and B, since these A and B are too close to each other. So when these A and B are too close to each other to the point that we are considering to just consider it as one point as T, it means that now this ceases to become just MB, or it ceases to become MA, but it becomes MT. So we would still say that MA times MB is equal to MC times MD. But now since A and B are the same, so then we shall simply say MT times MT is equal to MC times MD, just like we've done it here. That MA, from the first to the farthest, times from the first to the nearest, is equal to MC, which is from the first to the farthest, times MD, which is that MC times MD. And so when we write it, we do it like that, we end up with MT squared giving us MC times MD, just like that. Let's get to look at these two intersecting chords. We are having AB and CD right there. These two are intersecting at point M, and we are being told that two chords AB and CD of a circle are produced. They are produced to meet out at M, outside the circle. Now given that AM is 8.4, so from A to M is 8.4, BM is 5 centimeters, MD is 10 centimeters. Find the length of MC. So we need to find the length of MC. We are still going to use the property we've just done before. So to find the length MC, we shall say M times A, MA, times MB is equal to MD times MC. And it is MC we are looking for. So what is MA? MA, or what we are calling AM, there is no difference, is 8.4 centimeters. So this is going to be 8.4 centimeters. Multiply that by MB, which is the same as BM, which is 5 centimeters, times 5 is equal to MD. Now from M to D is 10 centimeters, which is 10 times MC, which we are looking for. So MC. So the rest is math. So our value of MC becomes 8.4 times 5, divide all that by 10. And we get our value of MC as 4.2 centimeters. In our next question, you are required, we are being told that there are two chords, AB and CD, of a circle, and they are produced to meet the circle at T. So these two chords are produced to meet this outside at point T, to meet outside the circle. So they are produced to meet outside the circle at point T. We are being asked to find length TD. So we are going to employ the same technique. TA times TB is equal to TC times TD. So we begin working. So it becomes TA times TD is equal to TC times TD. Now our value of TA from T to A is 5 plus 4, which is 9, times TD, it is actually TB, times our value of TB, which is 4 centimeters, is going to be equal to TC, which is 9. Remember, we're looking for this length and we do not know it, so let's call it X. So from TC is going to be 9 plus X times TD. TD is X. So our task is to find the value of X. So we know that 9 times 4 is 36. Is going to give us, this is going to be, opening this bracket is 9x plus x squared. So when we transfer this 36 to move that side, we shall remain with 0 here, and we form a quadratic equation, x squared plus 9x minus 36. So when you solve that quadratic equation, we'll get our value of x, two values of x. One value of x will be 3, and the other value of x will be negative 12. Of course, we shall go with a positive value because distance is positive. So it means our value of x here will be 3. This brings us to the end of this tutorial. Thanks for watching. For more videos, I encourage you to subscribe to this channel and also encourage you to share on other platforms. I hope you watch the next video. For Kisembo Academy, this is Arnold Rangakuramya.